trigonometry review for calculus. Trigonometric functions. As you know, there are 6 trig functions. Let's define them using a right triangle. So we got a right triangle here, and angle, reference angle theta. So the side adjacent to theta is A, opposite here, opposite side, O, hypotenuse. Okay. Then the first function, let's say sine of angle theta, but we write in short just sine, S-I-N, still called sine of theta, is defined as opposite over hypotenuse. Opposite over hypotenuse. And cosine of theta is adjacent over hypotenuse. Then tangent theta is opposite over adjacent. And we have their reciprocals. If we flip the ratios, then we get cosecant theta. And we were supposed to write parentheses, but we're just lazy, so we don't put parentheses. So this works. Cosecant is just the reciprocal of sine, h over o, or we can write 1 over sine theta. And reciprocal would be secant. Okay, secant is h over a, or 1 over cosine, and there is a cotangent, is just a reciprocal of tangent. Adjacent over opposite, or 1 over tangent. Okay, to memorize sine, cosine, tangent in terms of the ratios of 3 sides, we sometimes go by so, ka, to, wa. Sine opposite over hypotenuse. Cosine adjacent over hypotenuse. Tangent opposite over adjacent. And now cosecant would be reciprocal of that. Okay, cosecant is just h over o. Secant would be h over a, or 1 over cosine, and cotangent is adjacent over opposite, or 1 over tangent. I mean, these are reciprocals. Okay, and then we can put them here, and these are called reciprocal identities. In the same way, since cosecant is reciprocal of sine, sine is also reciprocal of cosecant. Okay, sine is 1 over cosecant, cosine is 1 over secant, and tangent is 1 over cotangent. So these are reciprocal identities. Then we have quotient identities, 2 of them. We know sine, if we find the ratio sine and cosine, sine is opposite over hypotenuse. This is adjacent over hypotenuse, and if we simplify, it's going to be simply O over A. So that is just 2r, right? O over A means tangent. So tangent is sine over cosine. Okay, that's just the tangent. And if we flip this fraction, that's the reciprocal, it's cotangent, cosine over sine. So we got 2 quotient identities. Tangent is quotient of sine and cosine, and it's reciprocal. Then comes Pythagorean identities. Okay, that's based on, again, the right triangle. When we have a right triangle, let's say angle theta. Let's say this one is side A, B, C, adjacent, opposite, hypotenuse. We know that a square plus b square equals c square. Okay, if I write opposite and hypotenuse, let's write that way, and adjacent is square, opposite is square, hypotenuse is square. If I divide by h square on both sides, this will be a over h square over h square, h square over h square 1. And now we have trig functions for these ratios. O over h, opposite over hypotenuse, let me put that first, that's the sine theta square, and sine theta square, this is kind of tedious to write. In short, we write sine square theta. Okay, sine square theta is in fact sine theta quantity square. That means sine theta times sine theta. This is just the shorthand notation. So opposite over hypotenuse square sine square theta plus adjacent over hypotenuse, that's the cosine square theta. I just put in different order, equals 1. So that's the most used Pythagorean identity. So sine square plus cosine square equals 1. And depending on our need, sometimes we need to write sine square in terms of cosine square and cosine square in terms of sine. So if we subtract cosine square from both sides, we get another identity, sine square theta, subtract cosine square theta from both sides. Okay, and if we subtract sine square from both sides, we get cosine square theta equals 1 minus sine square theta. Okay, these two identities are just derived from this one. Okay, this is only valid for a square. Okay, this does not mean, this is not true. Do not think, oh, I can take square root both sides, then write sine theta plus cosine theta equals 1. Okay, this is not true. And it's not true for cube or fourth power. It's only, look at here, Pythagorean theorem, a square plus b square equals c square type. So only for a square. Okay, so let me erase this one. In the same way, if we manipulate this around, then we get 1 plus tangent square equals secant square. And sometimes we might have to write tangent square in terms of secant square, then we can subtract 1 from both sides. So tangent square is subtract 1 from both sides, secant square theta minus 1. Okay. In the same way, 1 plus cotangent square is cosecant square. If you want to write cotangent square in terms of cosecant, then you subtract 1 from both sides. So you can just get another identity. So these are Pythagorean identities. Now, even odd functions, in our case, even odd identities are negative angle identities. Okay. Sometimes we got sign of negative angle. If the angle goes in clockwise direction, then that's a negative angle. Sine and tangent are odd functions. That means sine of negative theta is, just pull the negative outside, negative of sine, and tangent of negative theta is negative of tangent. But cosine is an even function. So cosine of negative is same as cosine of positive. So that negative will be just absorbed. And it applies for cosecant, same thing. Cotangent, same thing, it will be negative, and it's for secant as well. Okay, their reciprocals also follow the same rule. These are even odd. Then periodic behavior, periodicity, the sine values, sine and cosine. Okay, their values repeat after 2 pi, that's after 360. Sine of some angle plus 2 pi, then we get back sine of that angle. Same thing for cosine. For tangent, we don't have to wait until 2 pi. After 2 pi, definitely it repeats, but even before that, tangent theta plus pi, only if we go theta more, pi more, pi is 180, then we get tangent of theta. It's like tangent of, let's say, 30 plus 180 degrees, okay. Then this value, that's a 210. This will be same as tangent of 30. Okay, tangent theta plus pi is tangent of theta. So we'll see that when we evaluate values, okay, in the next section, next example, in the next video. That will be in the next video. So sine and cosine has period of 2 pi, but tangent has shorter, that's only pi. Now sum and difference formulas, sine u plus v, okay, and then here's one wording, okay, this is not true, okay, just simply distribute sine, or not, that's not true. No, because sine is not a product, it's not a factor that you can distribute, okay. What happens is, though, sine u plus b is in fact sine u cosine v plus cosine of u sine v. And if we have negative here, then this will be negative, everything else is same. In the same way, we cannot distribute cosine. Cosine u plus v is cosine u cosine v minus sine u sine v. Look at it, for plus, it's going to be minus. But if we have minus here, it's going to be plus. And rarely use tangent u plus v, that will be tangent u plus tangent v over this. If we have negative sign, then this will be negative on the top, and this will be positive on the bottom. Now if we take u plus u, another u, same angle, sine u plus u, that will be sine of 2u. That's a double angle. Then we get these formulas. It's double angle formulas. And as I said, we are supposed to write 2 theta. We are just lazy not to write. Sine 2 theta is 2 sine theta cosine theta. You can clearly see from here. If I put plus here, let me show you here. Okay, simple proof. That might help you to memorize in some cases. So if we make u plus u, v as u, then we will have this. So this will be sine of what? 2u equals sine u cosine u plus same thing, sine u cosine u. Same thing, so 2 copies of sine u cosine u. And if we say theta, the angle, sine 2 theta is 2 sine theta cosine theta. That's what we have here. Okay. In the same way we can do for cosine 2 theta. Cosine 2 theta is cosine square theta minus sine square theta. And depending on our need, because we know that sine square theta plus cosine square theta equals 1. And we can write sine square theta in terms of cosine, and we can write cosine in terms of sine. So cosine 2 theta has 2 more forms. Okay, let me write down. This one is same as, if I write cosine square equals subtract sine square from both sides, it's going to be 1 minus 2 sine square theta. So cosine 2 theta is cosine square theta minus sine square theta, or cosine 2 theta is this. Or if I write sine square is 1 minus cosine square, then that's minus 1 minus cosine square. This negative 1 need to be distributed. So we're going to get 2 cosine square theta minus 1. That's also a formula for cosine 2 theta. So cosine 2 theta has 3 forms, and depending on your need, we might have to use, I don't know, generally the second and third, or we can use first as well. In the same way, rarely used tangent 2 theta is this one. It's coming from these some formulas. Now we have power reducing formulas. These are used in integration. So sine square, we cannot do it, integrate. So 1 minus cosine 2 theta over 2, or a lot of times it's written as 1/2 times 1 minus cosine 2 theta. Okay, these are same algebraic expression. And in the same way, cosine square theta, 1/2, 1 plus cosine 2 theta. If you notice, sine square we got negative, for cosine square we got positive. Our tangent square is just a ratio, rarely used. Then now finally we got co-function. We got sine, cosine, right? And then cosine, sine, tangent, cotangent, and others, but the first two are used a lot. So sine pi over 2 minus theta is cosine theta. That's 90 degree minus theta, cosine theta. If I have theta, let's say 30, cosine 30, that will be then sine 90 minus 30, 60. Okay, sine 60 has same value as cosine 30. All that means. And same thing here. Cosine 90 minus theta, 90 degrees minus theta. But calculus works on radians, so we are using pi all the time. Okay, cosine pi over 2 minus theta is sine theta. Tangent, cotangent. And you can do for cotangent as well. And there is a secant, cosecant. That's why co-functions. Okay, final.